Exhalomics, we kind of make it, or in another word, exhale breath metabolomics. So by the name, you see this is a study of a volatile organic compound, but also gases released in exhale breath. Earlier we see a lot of research from human studies, from also mice studies. Basically, think about from monogastric, and these are breathborne metabolites that are coming out of the lungs. And we are researchers looking into it by analyzing what's in there. They have a lot of insights looking into the host metabolism and also health aspects.
So hello everyone, this is Luis Ferreiro with the Dairy Nutrition Blackbelt Podcast. And today we'll be talking everything about exhalomics. And if you don't know what that means, don't worry. To answer that question and a lot more about that, we have Dr. Mutian Niu, assistant professor at ETH Zurich. And Dr. Niu will give us a full overview on that. But before we go through all that discussion, first, welcome to the podcast. Can you give us a brief background about yourself?
Sure. Thank you so much, Luis, for the kind introduction and also the invitation. My name is Mutian Niu. As mentioned, I'm an assistant professor of animal nutrition at ETH Zurich in Switzerland. I was doing research and studying in the US for about a decade, Penn State and UC Davis, by training a dairy nutritionist and also a data scientist. Great to be here.
So let's start with a very simple question. What is exhalomics?
Yeah, it feels like a buzzword, right? And exhalomics, we kind of make it, or in another word, exhale breath metabolomics. So by the name, you see this is a study of a volatile organic compound, but also gases released in exhale breath. Earlier we see a lot of research from human studies, from also mice studies. Basically, think about from monogastric, and these are breathborne metabolites that are coming out of the lungs. And we are researchers looking into it by analyzing what's in there. They have a lot of insights looking into the host metabolism and also health aspects. For ruminant, for sure, this is very unique because when we look at ruminant animals, rumen play a big part, are constantly releasing gases, mainly released from the pressure of the headspace of the rumen, which kind of mix the eructation we call mixed in the normal breath. That's why there's a little bit special in there.
So tell us a little bit more about why did you decide to study this specific area and why we should pay attention to that from a dairy nutrition perspective?
Yeah, that's a good question. So as mentioned, I'm a dairy nutritionist myself, and a lot of research from my group, we're focusing on looking into developing nutritional strategies to mitigate greenhouse gas emissions such as enteric methane production. And then while doing that, obviously, I also want to take a look into rumen fermentation by measuring rumen volatile fatty acids, for instance. This was not a problem at all. One was US. We have a good amount, let's say, a good amount of rumen cannulated cows. We can also do tubing. So I've done a lot of those myself. So transitioning my position to Switzerland about 3 years ago in Zurich, but also in general in Europe, I found there's an increasing attention and maybe comparatively more attention, more strict measures. One, we are trying to conduct these researchers. So actually, these are maybe one of my first challenge I was facing when I first arrived when we are doing methane study. And the ICOG we call, the ICOG takes much longer time to get. And then that was pushing me to think about whether there's an alternative, non-invasive alternatives to look into the rumen fermentation, which is the very initial idea that come from giving a number. My students sometimes will talk about it in his presentations at ADSA. In whole Switzerland, we have 6 rumen cannulated cows. And in my research facility, we have 4. I mean, of course, we can do tubing, but that speaks about the limitations we have. But that also opened doors for us to explore exciting research areas such as exhalomics.
Absolutely. And I think that's a very creative way of going around some of those limitations. And certainly, there are a lot to learn whenever we start working with a different set of samples or a different set of measurements. So tell us, what did you discover with your research?
So when we start looking into exhalomics, particularly about the ruminant or cattle, we want to focus. I mean, I use different instruments to measure methane emission. We use chambers, and then we also use a high chamber system such as green feed, which is widely used. So when I started with my PhD, this is at UC Davis, I was also always observing these eruption events, and obviously there are some gaps in between. And then when look at the human studies, measure, for example, early detection of lung cancer or multi-cancer using breath, then I was thinking, can we capture what's there? So the first study I had in mind was trying to, we use green feed as a sampling device, and we sample basically the full eruption event right after we measure the methane emissions. This is in a tidal system, so we can be more controlled. And then we bring the sample, basically the exhalome, we call exhalome sample, into the lab using the analytical platform in a high resolution MS and to measure the profile of it. And then the first study we did is a characterization study because we have a good understanding of how acetate, propionate, butyrate, they fluctuate relative to feed intake. So we did that, and we compare with the feed intake pattern, feeding behavior, but also methane emission pattern. We found a relatively reasonable, similar to other study has done before. And then we went ahead to conduct another validation study by creating two distinct rumen profile, high versus low starch. And there we went in also doing both on the daily aspect and also look into diurnal pattern, where we found the two patterns from the rumen fluid VFA profile and also the exhalomics, or we call exhal VFA, they following up very well. And there we also trying to predict using a Henry's log constant by trying to predict the high space gas concentration there. So there, all three, we look into it, and we have a very good finding there. That was in the starch of 16% dry matter starch versus 6% starch, as we're using only a few cows. And now we want to go further to further evaluate in a much wider dietary conversation and the different dietary conditions how this exhalomic approach works.
Looking to maximize your herd's potential? Elevate performance with Kemen's cutting-edge encapsulation technologies, including rumen-protected choline, methionine, and lysine. Kemen's advanced choline and amino acid technologies ensure precise nutrient delivery, boosting milk yield and enhancing herd health. Trust Kemen, the experts in encapsulation, to take your herd to the next level. Learn more today at kemen.com/dairy.
Yeah, I think that's awesome because at the end of the day, if you are able to characterize, how the cow completely changed their rumen dynamics and obviously the eructation dynamics based on that, I think that's awesome because it allows us to measure so many more things and go from there. So said that, if you can put into a nutshell, what do we know today about exhalomics, and what do you think is next for this line of research?
Yeah, that's a great next question for the future. So we focus a lot on the rumen VFA, but from there we know that tells something. For example, we always have this debate between VFA concentration, molar proportion, without being able to measure, not so easy at least, the entire rumen load. And so moving next, we're thinking, one, we're looking into not only the VFA profile, now we actually develop prediction models. We are able to predict the rumen pH in a relatively good aspect. We're now collecting more data with the idea to whether provide an early prediction or a prediction of acidosis or SARA. And then we are also looking further into not only stay on the VFA level, we're also looking into using multi-omics approach by looking into how Exhalomics, where we identify thousands of compounds, and how can that reflect a rumen microbial activity. As we know, there we are doing metagenomics and metatranscriptomics, trying to get a snapshot of what's happening in there. But by directly looking into the metabolic profile, where eventually I hope we can get a real-time or more frequent measurement with non-invasive aspect to reflect rumen fermentation. But what's more, we actually starting to deviate our focus from just the rumen, looking into more like a normal breath, we call. So we went in and also established a SOP to kind of purify or trying to sample the actual cow breath that's with the least amount of contamination from the rumen irradiation. Actually, that paper was just accepted at the GDS communication, where we can see with a few biomarkers there a clear separation of the volatile fatty acid being really enriched in the we call exhalome overall. But then the other compounds, numerous compounds, we can see also clearly in the breath where we sample only between irradiations. So we are looking zoom into that. And from there, I think there's a bright future as my team is phenotyping both sick versus healthy animals, trying to identify important biomarkers leading into different diseases. There were some early work done by other groups looking into respiration diseases. There are several biomarkers being identified in farms in Colorado. Now we are not limiting ourselves to respiration diseases, but also ketosis, mastitis, metritis, dysplastic abomasum. And then we try to create a profile there and eventually led to further development of some on-site real-time end-to-end tools can really guide us through a precision farm management.
Yeah, I think that's fascinating, and I'm really looking forward to your next set of research trials and what you can learn and what we can learn about this very nice topic. And I hope we can have some tools to help dairy farmers in the future about that. So Mutian, thank you so much for joining us today. And you at home, thank you for joining the podcast. I hope to see you soon.
Thank you, Luis. Thank you very much.
Hey everyone, we are always searching for the latest and greatest research to share weekly. If you have a dairy nutrition related research trial and would like to come on the show and share it with us, feel free to email the details of your research to hello@wisenetics.com. Thank you and hope to see you soon.